Problem 7107, multiple strategies. JR's team is trying to find multiple ways to solve 3/4 equals x over 6 from problem 7106. With your team, analyze each of the strategies below. Some of the strategies might be the same as what you came up with in problem 7106. However, others may be new. Work to understand each strategy so that you can use it to solve a new problem. Part A, JR wants to use a giant 1 to help find the value of x. Explain how he can find a value to use as a numerator and denominator in a giant 1 and then find the value of x. Well, for this, what we are doing, and this is what we did in the previous problem, problem 7106, is we need to figure out what we can multiply by 4 to get 6. So I'm going to explain this. Let's say he needs to, or we could say JR needs to determine what he can multiply 4 by to get 6. And again, if you recall from problem 7106, rather than using trial and error, he works backwards and does 6 divided by 4 to get 1.5 to use as a numerator and denominator in the giant 1. So that's how he determines what he's going to put in the giant 1. Now, this, I did say he's not using trial and error to figure out, oh, well, 4 times what gives me 6. Now, these are pretty friendly numbers, so you could do trial and error, but that won't always be the case. So working backwards might be more efficient. I'm not going to solve this problem out because that's what we did in problem 7106, but that is the explanation we should have, at least, as to how he determined what to use as the numerator and denominator in his giant 1. Okay, let's take a look at part B. Looking at JR's work, Letitia said, I see it differently. We just need to find some number that when divided by 6, you get 3/4. We can undo the division by multiplying each side of the proportion by 6 like this. Then Letitia showed JR the work below. So with your team, explain how Letitia's idea works. Are the two ratios still equal? Why did she choose to multiply by 6? Simplify each side of the equation. So in this case, Letitia is multiplying both sides of the equation by 6 over 1. Are the two ratios still equal? So let's start with that part of the problem. We're going to say yes, they are. And why? Well, because Letitia changed them in the same way. She multiplied by 6 to keep the sides balanced. So yes, the ratios are still equal in this case. All right, now what we're going to do is simplify each side of the equation. Oh, really quick, we do need to answer, why did she choose to multiply by 6? So she chose to multiply by 6 because x is being divided by 6, as you see right here. So we'll say she chose to multiply by 6 because x is being divided by 6. So she's undoing that division by multiplying. All right, so let's go ahead and take a look, and we are going to solve through this or simplify both sides of the equation. So I'm going to copy that down right here. We have 6 over 1 times 3/4 is equal to x over 6 times 6 over 1. All right, so the left side I'm going to have 6 times 3, which is 18. I have 18 over 4. And then that is equal to x times 6 is 6x over 6. And if I have 18 over 4, remember that that fraction bar means the same thing as division. So 18 divided by 4 is going to give me 4.5. And 6x divided by 6 gives me 1x, or just x. All right, notice how we still get 4.5. Okay, so that's all for part B. Now let's take a look at C. It says, Avner asked, but if multiplying both sides by 6 gets rid of the denominator of the x, then can we use the same strategy to get rid of the 4 and the other denominator like when we do fraction busters, right? Discuss Avner's question and decide if undoing both denominators using a fraction buster is a reasonable strategy. Does this help solve the equation? All right, so let's see. It looks like, if we look at Avner's work, right here he has the 3/4 equals 6x. And he is multiplying by both denominators on each side. So basically what Avner did here, you can see he has 4 times 6 over 1 and 4 times 6 over 1 here. So he is using the fraction buster method to do this, like we did in problem 7106. So what he's doing is he's using that denominator of 6 here to multiply by 3 and 4 here to multiply by x. So again, in this case, once he gets to this point, we would have 18 equals 4x. And again, if we divide by 4 on each side, we still get that 4.5 equals x. So does his strategy work? Yes, his strategy does work. Now, it's just not as efficient as Letitia's. We will say Avner's strategy works. We just have an extra step in isolating the x. All right, and that is all for problem 7107.